if you are adding any of an element into the back of a queue, that means to the rear end of a queue, then we are going to call that as a NQ operation. We have only two pointer here, one is front and rear. Front is used to delete an element, rear is used to insert an element into the list of a queue. Why we are going to use this front? Mainly to delete the element. So if I don't have any element to delete, that indicates what? Queue is empty. Hello everybody, a warm welcome to one and all. Welcome to the first session of year chapter 3 and we are in the unit 2 of B.Ca second semester subject called data structures using C. So in this chapter 3 we are going to learn about the topics called queues. I am Rohini TS, Department of Computer Science, Vidhyaashram first grade college, the Temple of Excellence, MYSURU. So in our today's session we are going to see about this queues. As we all know that in the previous chapter of this unit, we have learned regarding a data structure called stacks. So in our today's session, we will be learning regarding a new data structure called queues here, and I will be discussing the definition and what is the basic information that I wanted to give regarding this queue. I will be giving, along with that, we'll see the representation of this queues in a computer memory along with the help of one-dimensional array. And also I will be discussing regarding what are the types of queues we have. Along with that, we'll see the operations, what and all can be performed on this queues. That is operations on queues. So in my coming session, you will be learning all the operations one by one along with the algorithm. So as of now, you are just going to get to know what are the operations that we have in a queues. So this will be the content of my today's session. Let me get into the first topic, that is regarding queue. Simply if I say queue, you all will going to imagine something, right? So what is that? One another people will be waiting for something. That is what queue in the sense, it will be a collection of some elements, collection of data elements. Who come first can stand in the first place. Who come next can be stand in the next places, isn't it? That is what same data structure we are going to follow in this queue scenarios also. So here you can see the definition. Queue is an order collection of items where an item is inserted at one end called rear. If you come up with the imagination of a stacks, already you got to know regarding stacks, right? Their insertion and deletion both will going to take place at the same end called top of a stack. But that is not the thing in the queue. So here insertion will be at the rear end and existing item is removed or deleted at another end called the front. So here we have two ends, one is rear end and another one is front end. So if you wanted to insert an element, then we have to use an end called rear. So if you wanted to delete an element from queue, then we have to use an end called front, right? And what was the thing that you have learnt in a stack? That is LIFO, last in first out. Which element we are inserting at last will be coming out first. But this is regarding FIFO, that is first in first out. Which element that we are inserting to the queue first, that will be coming out first. That's why it's considered as what? First in first out. And also in the queue we can perform the two operations. One is NQ and another one is DQ. NQ in the sense what? If we are adding a data elements, anyway it is a collection of or ordered collection of an elements or an items. So if you are adding any of an element into the back of a queue, that means to the rear end of a queue, then we are going to call that as a NQ operation. So if you are removing an element or if you are deleting a front item or an element from the queue, then we will be calling that as a DQ. So here you can see the representation. These are all the collection of an elements, right? If I wanted to insert a new element, so that will going to take place from the rear. That means at the back of a queue. So here we are performing a NQ operation. So it will come here. At last it will be stored in each place. If I wanted to delete it, that first element will going to be here itself. If I wanted to delete it, then I have to perform this DQ operation that will going to take place by the end called front, right? Then that item or an element will be out of a list of a queue elements, right? This is regarding what basic knowledge regarding the queues topic. So next, you can see here how we are going to represent this queue in the memory. That is what? Memory representation of a queue using an array. Already we know even array is what? Homogeneous element or a collection of homogeneous or same kind of elements. In this queue, it is also an ordered collection of elements, and insertion will be at the rear end, deletion will be at the front end. So it will follows last in, first out. Then it will going to follow FIFO, that is first in, first out. Then how we are going to represent this queue in a computer's memory, that too by making use of linear array. It will be a single dimensional array. We'll see how it will be represented. You consider we have an array called Q. So now I am taking array name as Q here. In the previous example, we made array name as A. So here we are considering a array as Q, and here we have a two pointer variable to specify the location. One is what? Front, and another one is rear. Already you know about the front and rear end of a queue, right? So if I am using a front pointer, that mainly specifies the location of an element that needs to be removed or deleted. So if you wanted to delete or remove any of a data item which we have in a queue, then we have to use this front pointer. Right? If you wanted to insert a new element, then we have this rear pointer that will going to contains the location of the last element which is inserted. So from that rear end, we will be inserting a new element into a queue. So here you can see the representation here. For every data structure, we have a memory representation. With the help of arrays, we are going to explain the memory location of or memory representation of each data structure. Right? So if it is a one-dimensional array, it can be row-wise or column-wise, but here we are using it as a row-wise, and here also we have certain condition that needs to be satisfied. If I wanted to insert an element, then I need to check for the vacancy of an element, whether is there queue is empty or not. If it is not empty, then we can't insert a new element. But if I am trying to delete an element which is not at all there in the queue, even that is also not possible. So for the insertion, we have to check for the vacancy of an element or vacancy of a memory space for that element. And if I wanted to delete the element, then I need to check whether that element is there or not. That is what we have to concentrate. We'll see the first condition here. Front is equal to null. So why we are going to use this front? Mainly to delete the element. So if I don't have any element to delete, that indicates what? Queue is empty, right? From the front pointer, we are going to delete. If front pointer is indicating as null, then that indicates that we don't have any elements to delete. That's why the queue will be empty. Then what about one more condition? Rear is equal to n minus 1. I'm at the last location of a collection of elements in a queue. Then that indicates that queue is full. So here you can see the representation. We have 6 elements placed here, that is starts with 0, 1, 2, 3, 4, and we have 5. So with the help of this rear pointer, we are going to insert a new element. So all we know that here we have 2 vacant places, right? If I wanted to insert one more element to this queue, we will be able to add. So why? Because it is not at the n minus 1. That means if I wanted to add one more variable called f, so again this will going to be reached to next location, then we can add. When it comes to the deletion, we have to delete an element with the help of this front, which is the least recently added. That is what? B here. Why? Because B is the first element that we added. So this is what? Least recently added, or this is the first element which we added to the set of elements in a queue. So if I wanted to delete C, I need to delete the B first, then C will be removed or deleted. So that which is inserted first will going to be deleted first. So if you consider this, we have a FIFO, first in, first out. So next C will be removed, D will be removed, and E will be removed. So by deleting one elements from a queue, then this front pointer will going to be come to that position wherever we have a element. So if that front pointer become null, that indicates we don't have any elements to delete. So if the rear in is at the n minus 1 position, then we can specify that queue is completely full. Fine. Here also you can see one of the example here. Front is equal to 1, rear is equal to 5. So that means if I wanted to delete an A, then it needs to be indicated by this front pointer. And if I wanted to insert a new element to the queue, then the rear pointer should be there. So this is friend is equal to 1, rear is equal to 5. Then what about next one? Item is equal to q of friend. So now I wanted to delete an element, right? So if I wanted to delete an element, I need to specify that with the help of this friend pointer. So if I am specifying q of 2 is equal to what we have in q of 2, that is b. So now I wanted to delete this b which is in the second location of a q array. So the friend pointer will going to be pointed here, this will come out, then friend pointer will going to be incremented by 1 and it will going to showcase its location to the next position. So that means we can delete this c. So if I wanted to add a new element, then I need to give the location for that rear, then in that position we can add a new element. For this representation, here we have a friend pointer at the location 2 and rear pointer at the location 5. So in the fifth position, we are adding an element called E and I am deleting an element called B. That is with the help of rear and friend pointer respectively. So that's all regarding how we are going to represent a queue by making use of a linear array. So now we'll see what are the types of queue that we have in a queue data structure. So it will be of 4 types. One is simple queue, circular queue, priority queue, and we have a double-ended queue. So these are the 4 types of queues that we have. So we'll see each type one by one right now. So here, first we have a simple queue. As the name indicates, we have a simple queue here itself. That means insertion occurs at the rear end of a list and deletion occurs at the front end of a list. This is just like a normal queue, whatever we have studied till now. So if I wanted to insert an element, then that needs to be takes place with the help of rear end. If I wanted to delete an element, that needs to be takes place with the help of this front end. So here you can see that we are declaring a queue with 6 elements. It starts from index 0 up to 5 we have here. So as of now, friend pointer is at location 1. That means I am deleting an element called A from the queue. And when it comes to the rear, if I wanted to insert an element, then it will be at the location 4 now. I am inserting an element called D to the location here. And if I wanted to insert E, then the rear pointer will come here. So we can add a new element, right? This is regarding simple queue. That means we have to understand that we have only 2 pointers here. One is front and rear. Front is used to delete an element. Rear is used to insert an element into the list of a queue. So next what we have, circular queue. As the name indicates, it will be in the circular motion. So the first element will be attached with the last element of a queue. So we'll see the definition here. A circular queue is a queue in which all the nodes are treated as circular. So it will be treated in a circular format so that the last node follows the first node. So front and rear both will be somehow in together here. You can see that here we have a 0th location, that is front element. So if I wanted to delete any element, then that needs to be takes place from the front. If I wanted to insert a new element, then we can specify the rear location here. So wherever we have a rear, that is for the insertion. Wherever we have a front, that is for the deletion. If I wanted to delete the second position element, this element or this position element, if I wanted to delete, at the time front will comes here. If I wanted to insert an element to the location 6, at that time rear pointer will be here. So the last element will going to have an attachment with a first element, or it will be followed by the first node or a first element. This is circular queue. Next what we have a priority queue. As the name indicates, we are giving some priority for the operation of NQ or DQ. That means for the insertion or deletion, we are doing it on some priority. So priority queue is a queue that contains items that have some present priority. So based on certain standards or a priority, we are inserting or deleting an element. An element can be inserted or removed from any position depending upon some priority. So in the further types of queues, we don't have this privilege. So if I wanted to insert, that should take place from the rear end wherever that rear end was present. If I wanted to delete, the first element needs to be deleted first. That is what FIFO we can call. But when it comes to the priority queue, if I wanted to delete or if I wanted to remove the element of third position or a fourth position, then the friend pointer directly will goes to that fourth position instead of being at the first location. Based on some priority, we will be deleting it. So here we have certain elements here. If I wanted to insert an element, so in between only we can add it. If I wanted to delete an element, then in between or wherever we wanted to delete, from which location we wanted to delete, we can do that. That can be happen only with this priority queue. What is the last type of queue that we have related to DQ or a double-ended queue? So what if we have both front end and rear end at both the ends? What if it is possible to do the deletion and insertion at both the ends? Then we will be calling that type as a DQ or a double-ended queue. It is a queue in which insertion and deletion takes place at the both ends. We can do the insertion and deletion at both the ends. So if you consider the previous type, so friend will going to be pointed to the first location. That means for the deletion, we have to use the front end. If I wanted to do the insertion, that will be at the rear end. But in this DQ or a double-ended queue, that insertion and deletion both can take place at both the ends. So from here only, I can add an element. From here only, we can delete an element so that both front and rear pointer will be there in both the ends. That is what the DQ or a double-ended queue. Both the ends will going to have both front and rear pointer, and deletion and insertion can be takes place at both the ends. Fine. So these are the types of queue that we can see. We'll see the next topic, that is what operations on queues. That means we can perform certain operations on this queue data structure. Which are those? Here you can see that when it comes to the operation, you should be understand that whatever we are going to use the function name along with the parenthesis. If we have this parenthesis that specifies the operation or a method, inbuilt it will going to have certain code. No need to write that code by the developer or by the programmer who is writing a program. Simply if you are calling this function or using this function in your program, automatically this will going to takes place. So what we have a first operation here, that is queue. That mainly indicates we are creating a new queue that is empty. If I wanted to insert an element, delete an element from the queue, first it is necessary to create a queue. How we are going to create then? That too with the help of this queue operation, that will going to create a new queue that will be of empty. If you wanted to insert an element, then I need to perform one more operation called enqueue. Fine. So in this enqueue of item, why? Because within the parenthesis, we are sending arguments or a parameter. So here I wanted to insert an element or an item. That is why we are sending a parameter in that enqueue function. It will going to add a new item to the rear of the queue. So why? Because if I wanted to insert an element, that should take place at the rear end. That will going to be done with the help of this enqueue operation. What if I wanted to delete or to remove the existing data item? That can be done with the help of this DQ. So mainly it will going to remove the front item from the queue. So where the front pointer is locating, from there we can delete an element from the queue. And how can I get to know whether do we have any element in the queues or not? Then we have a function or operation for that, that is empty. We are checking. That means do we have any values or whether the queue is empty or not. So if it is empty, then it will going to return true value. So if it is not empty or if we have some value, then it will return the false value for this is empty operation or a method. At last we have one more function called size. So that size specifies the total number of items in the queue. So if you consider the queue here 10, 20, 30, 40, let me consider queue of 0, queue of 1, and we have a queue of 2, and we have queue of 3. So if I'm using is empty operation on this queue, at the time it will be false. Why? Because we have elements. Queue is not empty. That's why it will going to return false. And if I'm using size function on this queue, then it will going to return 4. Why? Because it has 4 elements in it. And if I wanted to delete or if I wanted to have a dequeue operation, friend pointer will going to be pointed to this first element. So then this 10 will going to be removed from this queue. And if I wanted to insert one more element, rear pointer will going to be presented to the back or end of a queue. From there, we can insert a new element, right? If I wanted to create a blank queue which is of empty, then I have to use a function called queue. So these are the operations that can be performed on the queue data structure. I hope you all understood my today's session. In my coming session, we're going to see briefly regarding this operations on simple queue. So now we got to know that we have front and rear ends or rear pointer in the queue. Then how this NQ or a DQ operation will going to take place in the simple queue, that I will be discussing in my coming session along with an algorithm, and also we'll see what are the applications that I have on a queue. That means wherever we can implement or we can incorporate this queue operations or queue data structure in real-time existence. That is what I will be discussing with respect to applications on queues in my coming session. Until that, keep learning, keep on growing. Thank you.